Yeah, this is Rajesh Babu, and Department of Chemistry from DRBCC Hindu College. So now we'll discuss about the topic for inorganic chemistry part. Actually, that chapter only consists of 5 units. So the chemistry of F block element and coordination chemistry and application of coordination compounds and chemistry of binary compounds and concepts of acid and bases. And we have to follow the some of reference book and the familiar one J.D. Lee and P.L. Soni and Madan Maulik Tuli. And one more textbook is a Purian Sharma, is a familiar one for reference. So now let us consider the topic coordination chemistry. First, what are the terminology involved in coordination chemistry? So let us consider this example. So this is one of the coordination complex. Actually, this coordination complex consists of a coordination sphere, and the coordination sphere and consists of metal and ligand. There is central metal atom and ligands are present in coordination sphere. And the second one is coordination number, which indicate the total number of ligand present in the coordination sphere. And third one, this is called a ligand. There are various type of ligand is there, positive, negative and neutral ligand, but this is a negative ligand. And central metal atom, so having vacancy d orbital is must. So this is the essential condition for central metal atom. And this is called ionization sphere, is present outside the coordination sphere, either left hand side or right hand side. Then coordination, then this is called oxidation number, and a ferrous atom having the oxidation number become +2. That's why they accept the electron from the ligand. So that's why this is called a Lewis acid, and ligand when this is considered as a Lewis base. So now we go to the what is addition compound. See, when two or more salts are mixed in the fixed proportion and allowed to crystallize, then new type of compounds are formed, is known as addition compound. Clear? So these are basically classified into two types, that is called double salt, and one more example is addition compound. Sorry, one more example is coordination compound. Double salt and coordination compound. If double salt, those addition compound which are soluble in crystallized form and get 100% ionized. So this is called double salt. For example, the cannelite and the potash alum is one of the best example for addition compound, because these compound get 100% ionized. But if a coordination compound do not get 100% ionized, because it consists of ionization sphere as well as the coordination sphere. So that's why it do not get 100% ionized. So let us discuss some important terminology related to coordination complex. Central metal atom, you know very well. The metal atom or ions which have the same or nearly same energy vacant orbital. That's why they accept lone pair donated by ligand. Central metal atom or ion behave as a Lewis acid. If ligand any atom molecules or ions which have lone pair to donate central metal atom or ion, ligand behave as a Lewis base. So those metal is accept the lone pair of electron, it act as a Lewis acid. And those element they donate the pair of electron, this is act as a Lewis base. So that's why central metal atom Lewis acid, ligand one is act as a Lewis base, right? So next we have to discuss about the types of ligand. The first one is monodentate ligand. See, It consists of only one donor atom. For example, H2O, aqua, it acts as a ligand. Second one, amine, is act as a ligand, monodendrite ligand. Cyanide is also act as a monodendrite ligand. And halido, for example, fluorido, chlorido, bromido, and iodido is there, and is also act as a monodendrite ligand. The charge when they become -1, but water and amine, the charge when they become 0. And some other examples for monodendrite ligand, hydrido, hydroxo, and nitro, then nitrito is some other example for monodendrite ligand, and also having the charge become -1. The second one is a bidendrite ligand. So which you have two donor atom is called a bidendrite ligand. For example, oxalato ligand, this is called a symmetric bidendrite ligand because having two donor oxygen atom, the charge become -2. And one more example is ethylene diamine. Here two donor nitrogen atom is there, the charge